These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There is a link to my website in the info box. The address is www.freelance-teacher.com/videos.htm, or you can just use the link in the info box. By the way, I also offer tutoring via Skype, and you can find more information about that Skype tutoring service at my website. Thanks. What is the purpose of NMR? Well, we know that when we're reading the textbook will kind of tell us, here's your starting materials. And if you put in these starting materials, here's the product that you'll get. And they'll just draw you a picture of that product. But how do they know that that's the product? Obviously, they know that's the product by having done the experiment, right? They've done the experiment with those starting materials, and they've seen what product they got. But still, how do they know that that's the right picture for the product they got? Because as you guys know from your own lab work, when you actually do an experiment, you don't see a little model with little bonds and atoms inside the beaker or the flask. You can't actually look at the molecules that you're making. So all the time that we're really reading the textbook or going through examples on the blackboard, we've been kind of skirting over this very big issue, which is how do people actually know what the structures of the molecules are? Well, that's what the whole purpose of NMR is. NMR is a technique that allows you to figure out what the structure of the molecule is. However, NMR isn't magic. It doesn't just tell you what the structure is. You have to work it out like a puzzle. NMR gives you a bunch of different, so maybe the best way to put it is NMR gives you clues as to what the structure of the molecule is. It gives you a bunch of different clues, and then you have to put those clues together like a puzzle to figure out what that actual structure is. And that's why I was saying whether this is hard or easy just depends on how hard the questions are that they give you. They can give you questions where it's quite difficult to put together the clues or where it's pretty easy. But we'll start with the basics, and then we'll work our way up. Okay, so in NMR, what are we doing? Well, first of all, we are shooting radio waves at the sample. So we have some unknown sample, and we're trying to figure out what it's made of. Some unknown sample, and we want to figure out what it is. So we shoot radio waves at it. Usually we have a set level of radio waves. For example, doesn't always have to be this way, but you might be shooting 60 megahertz radio waves, 60 megahertz radio waves, and you're going to measure when are those radio waves absorbed by the sample. If you can see the absorption, that will be a clue as to the structure. And the thing that allows the sample to absorb the radio waves is that you're also imposing an external magnetic field. So you set the radio waves at a certain level, say 60 megahertz, and then you start changing the external magnetic field. So usually you're going to have a set radio waves emission that you're transmitting, and you're going to be changing the external magnetic field. And when the magnetic field gets to the right level, the sample will be able to absorb the radio waves. Since we're just doing an introductory coverage today, and since our time is limited, we won't go into too much detail about exactly the mechanics of this, because usually when you're solving problems, they're not asking you about the mechanics, they're just giving you an NMR results and asking you to interpret it. So we want to spend almost all our time today on how to interpret the results. So we'll just spend a minute or two more on where the results come from. But the basic place they come from is basically when you get that printout of the NMR results, it tells you when the sample absorbed the radio waves. And the reason it's able to absorb the radio waves is because of this changing external magnetic field. When the magnetic field is at the correct level, you get an absorption. When the magnetic field is at the correct level, you get an absorption. So you keep changing the magnetic field until you notice that the radio waves got absorbed. And then the computer makes a note that they got an absorption at that particular magnetic field. Now the reason we can use this to determine the structure is, and we're going to be focusing on proton NMR. So we're going to be focusing on how the protons absorb radio waves. So obviously all of our organic compounds have protons, and we want to measure when do the protons in the compound absorb the radio waves. And the reason this is useful is that different protons will absorb the radio waves at different magnetic fields. And what magnetic field they absorb at depends on the environment that they're in. A proton in one environment will absorb when the magnetic field is at one level, and a proton in a different environment will absorb when the magnetic field is at a different level. So if we make a note of what magnetic field had to be in order to absorb the radio waves, then that's a clue as to what the environment of the proton is.
Is each proton unique, or do some of them absorb the same level?
Yeah, that's a good question. That's going to be one of the main things we're going to have to start off on. It turns out that some of the protons will be equivalent and some of them will be different. And that's one of the main skills that you're likely to be tested on, telling whether two protons are equivalent or different. And the practical importance of that is if two protons are equivalent, then they'll both absorb at the same field. But if two protons are different, they'll absorb at different fields. And what you'll see on your results are, if all the protons were the same, you would only get one peak on your results. You would only see one absorption. But if you have two different sets of protons that are different, then you get two peaks. Two absorptions on your printout. So that'll clarify in a minute or two when we start looking at some practical examples. So some protons are equivalent and some are different. And one of the very first skills we have to go over is how to tell whether the protons are the same or different. Like I said, we won't spend too much time on how this works. Maybe we'll cover what we needed here. So you change the magnetic field until the protons absorb, and then you change it some more, and maybe some different protons will absorb. And then you change the magnetic field some more, and some different protons will absorb. And the computer makes a note of all the different levels of the magnetic field where you got an absorption. And you can use that as clues as to what types of protons exist there. So again, the name of this technique is Proton NMR. Do you guys know what the NMR stands for?
Nuclear magnetic resonance.
That's right. All right, and now we can understand the different parts of this name. Why is it called Proton NMR? Because we're measuring the absorptions by the protons. There are different types of NMR, but today we'll focus on Proton NMR. Why is it called nuclear NMR? Well, it's the, so put another way, it's called proton NMR because we're focusing on the hydrogen absorptions. And we know that people oftentimes call hydrogens protons, loosely speaking. So what we're really focusing on is the absorptions by the hydrogens. And that's where that word proton comes from here, because oftentimes proton is used as a kind of synonym for hydrogen. There are other types of atoms that can also have absorptions, but we probably won't get to that today. And I don't even know if we're going to be covering that. But proton NMR is the key. Okay, why is it called nuclear? Because it's actually the nucleus of the atom that does the absorption. It's the nucleus of the atom that does the absorptions. That's where the nuclear comes in. Why is it called magnetic? Because the absorptions are facilitated by this external magnetic field. And in this context, resonance is basically a synonym for absorptions. You have a resonance when you have an absorption or a peak on your printout. So it's called resonance because we're studying when the nucleus is going to absorb or resonate with the radio waves.
I have a question. Is this thing NMR? Spectroscopy?
This looks like infrared spectroscopy.
Yeah, it is. Okay. So that's different.
Yeah, so there's many different types of spectroscopy. All the different types of spectroscopy are ways of trying to get clues about the structure. NMR is one type of spectroscopy, but what you were showing me was a printout for infrared spectroscopy. After all, remember, what we're shooting here is radio waves. And for IR, you'd be shooting infrared, electromagnetic radiation. Okay. All right, infrared is also important. Usually NMR is the most important tool, though, for spectroscopy. Okay, by the way, if I remember correctly, you guys have heard of MRIs, right, that you get at the hospital? I think that's what this is. MRIs are this, but I think the story is that patients didn't like being put into a device called nuclear. It had bad connotations, you know, so they gave it a new name. They gave it a new name because they didn't want to tell people they were putting them in a nuclear device, basically. All right, so I believe that an MRI is basically just doing this.